When Elon Musk made his latest announcement, even Tesla's biggest critics went silent. It wasn't just another product launch, it was a direct challenge to the entire EV industry. In one short presentation, Musk revealed something so advanced that experts are calling it the iPhone moment of battery technology. A battery so powerful it can double your car's range, charge in just minutes, and make electric vehicles cheaper than ever before. But here's the twist: this wasn't supposed to happen yet. Even insiders claimed this technology was being quietly suppressed online, until Musk decided to reveal it himself. So what exactly is Tesla's new condensed battery, and why are companies like BYD and CATL suddenly in panic mode? Because what Elon Musk just unveiled doesn't just power cars, it could power the entire future. When Elon Musk took the stage, no one expected what came next. The announcement wasn't teased, no grand countdown, no overproduced spectacle. Just a quiet slide, a few numbers, and silence. For a few seconds, even the livestream chat froze, because what he said next rewrote everything the EV world thought it knew. Tesla's new condensed battery wasn't another upgrade. It was a declaration that the race for the perfect electric car was officially over, and Tesla had crossed the finish line first. Within minutes, headlines exploded across social media, investors scrambled, and even rival engineers started dissecting the reveal frame by frame. Rumors spread fast. Some claimed the technology had been ready for months but was being held back to avoid market chaos. Others said Musk pushed it out now to challenge the rising dominance of Chinese battery giants like BYD and CATL. Whatever the truth, the message was clear: the quiet war for energy supremacy had just gone public. And it's not hard to see why this caused such shockwaves. A full charge in 15 minutes. Nearly double the range. Lower cost. Higher safety. Every single pain point of EVs, solved in one announcement. For consumers, it sounded like magic. For competitors, it sounded like a nightmare. But here's the thing: this moment didn't happen overnight. What Musk unveiled on that stage was the result of nearly 15 years of obsession, a journey that started long before Tesla was a global name. Because to understand how we got here, we need to go back to where it all began, when Tesla was just a dream, and the world still laughed at the idea of battery-powered cars. Before Tesla became a trillion-dollar name, it was just a handful of engineers trying to prove the impossible: that batteries could compete with gasoline. Back then, the world laughed. Analysts called it a Silicon Valley fantasy. But Musk didn't just want to make an electric car. He wanted to reinvent energy itself. Over the years, Tesla experimented with hundreds of chemistries: lithium-ion, lithium iron phosphate, solid-state, each one promising miracles, each one hitting walls. The problem wasn't power, it was density. More energy meant more heat, more risk, and more cost. And for years, every attempt to fix one problem only made another worse. Then came a quiet partnership few people noticed. Deep inside Tesla's battery research lab, engineers began working with a small materials startup rumored to have developed a breakthrough in high-nickel condensation, a process that allowed lithium particles to pack tighter without overheating. It was risky, expensive, and way ahead of its time. But Musk gave them one instruction: push it until it breaks. What followed were years of trial, failure, and near disasters. At one point, insiders say the project nearly got scrapped after multiple prototypes overheated during testing. But instead of walking away, Musk doubled down. He brought in AI-driven modeling systems, the same kind used in SpaceX rocket simulations, to predict microscopic battery reactions before they happened. And that changed everything. Within months, the team unlocked something no one thought possible: a condensed cell structure that packed nearly twice the energy of a conventional battery, with half the degradation rate. For the first time, range anxiety wasn't just shrinking, it was disappearing. But Tesla didn't announce it right away. For almost 2 years, the company stayed silent, quietly refining the chemistry, locking down patents, and building new gigafactory modules designed specifically for this next-generation battery. The secret was out there, but buried deep in research papers and prototype filings that only a few people noticed. Until now. Because when Tesla finally stepped on stage to reveal it, the world realized something: this wasn't just about cars anymore. It was about control over energy, markets, and the future itself. On paper, the numbers looked unreal. A battery that could deliver over 1,000 kilometers of range, charge from zero to full in under 15 minutes, and last nearly 3 times longer than current packs. But this wasn't science fiction anymore, it was Tesla's new reality. The secret lies in the condensed structure. Unlike traditional lithium-ion batteries, where energy density is limited by spacing and heat, Tesla's new design compresses energy into ultra-dense layers while keeping temperatures stable. In simple terms, it's like fitting the power of a semi-truck into the weight of a smartphone. That means smaller, lighter cars, cheaper production, faster acceleration, and for the first time, the possibility of mass-market EVs that cost less than gas cars. Imagine a Tesla for under $25,000, not in a decade, but possibly within the next 2 years. But this breakthrough doesn't just shake the auto industry, it threatens to rewrite the rules for every company tied to energy. Battery suppliers, oil giants, even utility grids suddenly face an uncomfortable question. If Tesla can produce condensed cells at scale, what happens to everyone else? Experts say this could trigger a battery arms race unlike anything before. Rivals like BYD, CATL, and Panasonic are already accelerating their own condensed cell projects, fearing Tesla could lock down patents that give it a decade-long lead. And then there's the bigger play, energy storage. Tesla's new battery tech doesn't stop at cars. The same chemistry can power homes, cities, even entire nations. Imagine solar panels charging ultra-dense storage systems that keep your house running for a week. No noise, no emissions, no blackout fears. In short, Tesla isn't just building a better car battery. It's quietly building the backbone of a post-oil civilization. But every revolution comes with a price. Because as Tesla was perfecting this battery, whispers began spreading through the industry that some companies didn't want this technology to reach the public just yet. And what happened next changed everything. As soon as Tesla's condensed battery leaked to insiders, the reaction behind closed doors wasn't excitement, it was panic. Because if what Musk promised was real, it wouldn't just disrupt automakers. It would collapse entire business models built on fossil fuels, maintenance, and battery dependency. Within weeks of the first whispers, analysts noticed something strange. Reports and research papers discussing condensed cell breakthroughs began quietly disappearing from online archives. A few scientists who'd mentioned working on similar technologies suddenly went silent on social media. Coincidence? Maybe. But to people watching closely, it felt like someone didn't want this story spreading too fast. Some insiders claim pressure came from the top of the energy chain: corporations, investors, and even governments with deep stakes in oil and traditional manufacturing. After all, if electric cars suddenly became cheaper, faster, and longer lasting than gas cars, the global energy balance would tilt overnight. Then came the rumors, quiet but persistent, about backroom negotiations between Tesla and major suppliers. It said that several big names tried to buy into the technology early or even delay its release until they could catch up. But Musk, true to form, refused. He'd spent too long fighting resistance from the old guard to let anyone slow him down now. And that decision didn't go unnoticed. Within days of the reveal, some media outlets began calling the condensed battery unrealistic, claiming it was overhyped or even impossible to mass produce. Yet behind the headlines, Tesla's factories were already preparing new production lines, machines specifically designed for this next-gen chemistry. It wasn't the first time Musk had been doubted. But this time, the stakes were higher. Because if the condensed battery reached full production, it wouldn't just make Tesla untouchable, it would redefine the global energy order. And Musk wasn't stopping there. He had another plan brewing, one that could push Tesla far beyond cars and batteries, straight into the heart of the world's power grid. To most people, Tesla is just an automaker. But to Elon Musk, that's only the surface. His real obsession has always been energy control, creating a world where power generation, storage, and use all flow through one ecosystem. And the condensed battery is the missing piece. Once this technology proved it could scale, Musk's focus quietly shifted. Insiders say Tesla began redesigning its megapack systems, the massive energy storage units already powering cities in California and Australia. But this time, the condensed cell version would hold 3 times more power in the same space. That changes everything. With these batteries, entire neighborhoods could run off stored solar energy without touching the grid. Factories could operate off renewable power alone. Even remote areas could go fully off-grid, all using Tesla tech. And that's where things get even more strategic. Because every megapack, every Powerwall, every supercharger that uses this new chemistry feeds into the same ecosystem, Tesla Energy. A silent empire being built under everyone's noses. While competitors were busy fighting over EV sales, Musk was quietly laying the foundation for something much bigger: a decentralized, renewable energy network that could one day rival traditional utilities. And the condensed battery made it possible. But what really shocked insiders wasn't just Tesla's ambition, it was the speed. Reports surfaced that the first condensed megapacks were already in limited production, with secret pilot programs running in Europe and Asia. Musk even hinted at it on X, writing cryptically, "Energy is the real revolution." If this expansion succeeds, Tesla won't just sell cars, it'll power homes, cities, and industries. It'll own the energy pipeline from sunlight to socket. And while the world is only beginning to understand this move, Musk's rivals are already scrambling. Because once Tesla's condensed energy network is in place, it may be impossible to catch up. But this bold expansion came with new challenges and new enemies. Because not everyone wants Musk controlling the future of power. When Tesla's condensed battery announcement hit the headlines, the reaction wasn't just local, it was global. Within hours, stock markets trembled, oil prices dipped slightly, and every automaker from Tokyo to Munich went into crisis meetings. Because if Musk's numbers held true, the EV timeline had just jumped 5 years ahead of schedule. In China, where BYD and CATL had been dominating battery innovation, the response was immediate. Engineers reportedly worked through the night, analyzing every frame of Tesla's reveal, comparing it to their own prototypes. One insider leaked that BYD was already preparing its own supercondensed design, but admitted privately that Tesla's breakthrough came sooner than anyone expected. In Europe, BMW and Mercedes executives called emergency briefings, worried about being left behind in the premium EV segment. Even Toyota, known for its cautious pace, was said to be fast-tracking its solid-state program just to stay in the race. But beyond the car industry, the shockwave hit even harder. Energy ministers in several countries began re-evaluating their grid strategies. If Tesla's new megapacks could store triple the energy, entire regions could shift away from coal or natural gas years ahead of schedule. Some governments even began reaching out to Tesla for early partnership talks, something that would have been unthinkable a decade ago. Meanwhile, oil producers quietly grew nervous. Reports surfaced of energy lobbyists pushing back against accelerated EV incentives, trying to slow the transition. But the momentum was already too strong. The world had just seen a glimpse of a future where gas stations became relics, replaced by ultra-fast charging hubs powered by the sun. For the first time in decades, the balance of power was shifting, not through politics or war, but through technology. And at the center of it all stood one man, and one company, holding the key to the world's next energy revolution. But as Musk's vision gained traction, something else started to unfold, a series of mysterious delays, quiet rumors, and online leaks suggesting that not everything inside Tesla was running smoothly. And what surfaced next left even the most loyal fans questioning what was really going on behind the scenes. Behind the glowing headlines and viral excitement, Tesla's internal atmosphere was far from calm. While the world celebrated the breakthrough, whispers began spreading through the company's own hallways. Whispers of rushed production schedules, supply shortages, and mounting pressure from Musk himself. Sources close to the project described sleepless weeks inside the gigafactories. Engineers were being pushed to scale the new condensed cell design faster than ever before, but this was uncharted territory. Early production lines faced unexpected heat regulation issues, forcing entire modules to be rebuilt from scratch. Every hour of delay meant millions lost, and every fix had to happen in real time. Some employees even claimed the tension reached a boiling point when internal test results leaked online, showing that early condensed cells degraded faster than projected. Critics pounced immediately, calling the technology overhyped. But internally, Musk reportedly called it just another hurdle. He told the team what he said since Tesla's early days: failure is just data in disguise. Yet, there were signs of deeper issues. Several top engineers quietly left the company in the months following the reveal, citing burnout and creative clashes. Others hinted that Musk's relentless pace, combined with the pressure to outpace China's rapidly advancing battery sector, was stretching Tesla's team to the limit. Still, despite the internal storm, production didn't stop. Gigafactories in Nevada, Texas, and Berlin continued upgrading, adding new lines for condensed cells while Musk personally oversaw progress updates. His focus never wavered, not even as investors began asking hard questions about costs, delays, and scalability. Because for Musk, this wasn't just another project, it was the project. The one that would define Tesla's legacy for decades. He knew that once the first wave of condensed battery Teslas hit the road, every critic would have to rethink what was possible. But deep inside the company, a few engineers noticed something unusual about the prototypes, a small detail buried within the battery software system that hinted at a function no one had mentioned publicly. And when word about that secret started to leak, the story took an unexpected turn. Just when it seemed Tesla had revealed everything, a small but powerful detail emerged, one that even seasoned analysts had missed. Inside the condensed battery, embedded in the software controlling energy flow, was a hidden optimization system that could dynamically adjust power output, efficiency, and longevity based on real-time usage patterns. In simple terms, the battery wasn't just powerful, it was smart. It could learn how a car, a home, or even a grid used energy, and automatically tweak performance to maximize range, reduce heat, and prevent wear. For consumers, This meant fewer charges, less maintenance, and an invisible layer of protection that extended the battery's life far beyond anything previously possible. But the implications went even further. Some insiders suggested that this system could link multiple condensed batteries together, from cars to Powerwalls to megapacks, creating a distributed energy network that communicates and balances itself. Suddenly, Tesla vehicles weren't just cars. They were nodes in a smart energy grid, capable of feeding electricity back and forth depending on demand. Competitors were stunned. BYD, CATL, and Panasonic had been racing to improve energy density and cost, but no one had thought to make batteries intelligent. Musk had quietly combined hardware and AI to create an energy system that adapts, protects, and evolves. Even more intriguing, there are whispers that this secret feature could eventually integrate with Tesla's autonomous systems. Imagine a network of vehicles and home batteries coordinating to reduce strain on the grid during peak hours, or dynamically rerouting energy where it's needed most, all without human intervention. This wasn't just a battery breakthrough. It was a glimpse into a new kind of energy intelligence, one that could redefine how we power our world. And while Tesla has only hinted at these capabilities, engineers say the potential applications are almost limitless, from electric aviation to smart cities, and even interplanetary energy storage for SpaceX missions. But with great innovation comes inevitable scrutiny. Governments, regulators, and competitors are all now watching Tesla more closely than ever, because once this system scales, the rules of the energy game will no longer apply. And that leads to the ultimate question: what comes next, and who will control the future of energy? The moment Tesla unveiled the condensed battery, the EV industry entered uncharted territory. Overnight, competitors realized that incremental upgrades were no longer enough. The game had changed completely. Energy ecosystem. Even the most advanced battery is useless without a reliable supply of raw materials. Tesla's condensed battery relies on high-purity lithium, silicon, and nickel, each with its own challenges: scarcity, geopolitical risks, and environmental concerns. Scaling production to meet global demand is not just a technical hurdle, it's a high-stakes strategic gamble. Silicon, for example, must meet ultra-pure standards for the nanowire anodes. Any impurity can reduce performance or even cause battery failure. Lithium, while abundant, is unevenly distributed across the globe, and mining it sustainably is a constant concern. High-nickel cathodes also require careful sourcing to avoid over-reliance on unstable markets. Musk's solution has been bold. Tesla is securing long-term contracts, investing in mining operations, and exploring recycling programs to create a sustainable supply chain. The goal isn't just to produce condensed batteries, it's to control the entire ecosystem, from raw materials to production lines. But it's a race against time. Competitors like BYD, CATL, and Panasonic are also expanding, and geopolitical tensions can quickly disrupt supply. A delay in material acquisition could slow production, frustrate consumers, and give rivals a chance to catch up. Tesla's gamble is also financial. Building facilities to process these advanced materials requires massive capital investment, advanced machinery, and highly skilled labor. The risk is enormous, but the payoff, a decade-long lead in battery technology, is potentially unmatched. In short, the condensed battery isn't just a technological breakthrough, it's a supply chain revolution, one that could reshape global mining, manufacturing, and energy economics for decades. Tesla's condensed battery isn't limited to roads. Its high energy density, rapid charging, and long lifespan open the door to entirely new forms of transportation. Electric aircraft, once a distant dream, are suddenly within reach. Planes could fly longer distances, carry heavier payloads, and recharge faster than ever before, all without the environmental impact of fossil fuels. Drones and autonomous aerial vehicles also stand to benefit. With condensed batteries, delivery drones could cover entire cities without needing constant recharging, transforming logistics and urban mobility. The same technology could even power personal flying vehicles, making the concept of urban air taxis less science fiction and more plausible in the near future. The impact doesn't stop at the skies. Condensed batteries could revolutionize shipping and freight transportation. Electric trucks and ships, previously limited by battery size and weight, could now achieve longer ranges and heavier loads. The ripple effect is enormous: cleaner ports, quieter cities, and a significant reduction in global carbon emissions. Even autonomous vehicles on the ground would benefit. Intelligent energy management, combined with condensed batteries capacity, allows fleets of self-driving cars to operate longer and charge faster, reducing downtime and boosting efficiency. In essence, Tesla isn't just building better batteries for cars. They're laying the foundation for a complete transformation of mobility, on roads, in the air, and across seas. Every vehicle that runs on electricity, every device that stores energy, is now part of a future Tesla is shaping, where range anxiety and charging limitations become relics of the past. This is more than innovation. It's the first real step toward a world where energy is portable, abundant, and smart enough to power everything from your home to your commute to the skies above. Tesla's condensed battery is more than a technological breakthrough, it's a statement about the future Musk envisions. For years, he has spoken of a world powered by clean, abundant energy, where technology solves problems that once seemed insurmountable. This battery is the first tangible step toward that future. Imagine cities where homes are powered by renewable energy stored in compact, intelligent batteries. Streets are quiet, skies are cleaner, and power outages are nearly eliminated. Devices from smartphones to laptops no longer demand daily charging. Even airplanes could run on electricity, reducing emissions and making global travel more sustainable. This isn't just about technology, it's about reshaping human life. Energy independence becomes personal, giving families, businesses, and governments unprecedented control over how power is produced, stored, and consumed. The condensed battery enables smarter grids, more efficient renewable energy use, and innovations that were once considered science fiction. Musk's vision extends even further. Tesla's approach could lay the groundwork for quantum batteries, superdense energy storage, and AI-managed power systems, where machines optimize energy use in real time. Every innovation feeds into a larger ecosystem, a world where energy is limitless, safe, and available to everyone. Yet, the path forward is as challenging as it is exciting. Scaling production, managing global supply chains, navigating regulations, and earning consumer trust are battles Tesla must fight alongside the technological revolution. But history shows that when Musk sets a vision, he pushes beyond obstacles and redefines what's possible. Tesla's condensed battery is not just a product. It's the beginning of a global energy revolution, a pivot point where the future of transportation, technology, and human life starts to change dramatically. And while competitors scramble and governments adjust, Tesla is quietly building a world that runs on smarter, cleaner, and more powerful energy. The revolution is no longer coming. It's here, and the question is no longer if the world will adapt, but how fast it will catch up. Tesla's condensed battery isn't just another upgrade, it's a revolution that will reshape the way we live, work, and travel. From cars that run over 600 miles on a single charge, to homes powered entirely by renewable energy, to devices that last days instead of hours, this technology is rewriting the rules. Elon Musk's vision goes beyond vehicles or gadgets. It's about creating a world where energy is abundant, smart, and sustainable, where the limitations of today become the possibilities of tomorrow. Competitors are scrambling, regulators are watching closely, and consumers are beginning to dream bigger than ever before. This battery isn't just Tesla's triumph, it's a turning point for the entire EV industry, renewable energy, and human innovation itself. The condensed battery opens the door to electric aviation, AI-managed grids, multi-sector energy systems, and even the next breakthroughs we can't yet imagine. As the EV revolution accelerates and technology continues to evolve, one thing is clear: the future belongs to those who innovate boldly and act decisively. And with Tesla leading the charge, the world is witnessing the dawn of a new energy era. So, whether you're a tech enthusiast, an EV owner, or someone curious about the future, this is the moment to pay attention. The innovations of today are shaping the life of tomorrow, and the story of Tesla's condensed battery is only just beginning.